All right, everybody, welcome back to another Ask a Dev Unreal Engine Quickplay challenge tutorial. Today's challenge is making a wheel roll using control rig. So we basically a procedural wheel roll. One of our community members is working on this, so it's a great little, can we get a quick video out to help answer their question? And it's also a fun thing for us to try to do with control rig. As I've mentioned before in previous Quickplay videos, these are unscripted and unrehearsed, so this is maximum fumble time. We're probably going to make a lot of missteps along the way, but that's part of why it's fun. If you like what we're doing, the usual stuff, helping support the channel, we have the tips down below, we have the Patreon, we have the community, hop in the Discord, and also spreading the word is awesome. So let's not delay too long. Now, I did cheat a little bit on this one. I did make a wheel. So before I started the recording, I did at least make a wheel. And so just a real quick what this wheel is. This is the wheel from the car project in the Epic's games. Let's see here, where is it? Samples, I think it is. There's a car sample, yes. So basically this car configurator, I stole the wheel from there. If you're wondering where I got it, pulled it into Maya, rigged it up. The thing to be, the thing to note is we've got just a very simple joint chain in here. So the challenge is making the wheel roll, not building an awesome car rig. So let's get to it. All right, first thing we need is a control rig. So let's create a control rig. Let's open that up. And I'm going to dock it, and I'm also going to do the usual, make this a little bit bigger for you all to be able to read. Okay, so here's what I'm thinking, and the thing that we've been kicking around with the ideas on this. In order for this to be a procedural roll, we kind of need a concept of time. This rig is going to move through the scene, and what we need to do is we need to store the current position as the previous position. This may not make sense if you've never done this, but that's generally what I've seen done in some other tutorials. So first, let's just create controls for everything. I'm going to do new, add controls for selected. Let's pick them all, and let's set them to, I'm going to do circle thicks, and let's rotate them 90. Oh, interesting. They didn't all update. Oh, that's wild. I actually had to compile that time. I've never seen that before. Okay, so that's not the direction we want to rotate. Also, full disclosure, I probably have not, actually we're only going to change the root. I didn't even check the joint orients on this. It doesn't matter. What is important will be eventually, let's try 10 and 10. And that's fine. I do actually want, I'm gonna make this, I wanna have some directionality to this so I can see which way I'm going. Making sure that the wheel is tracking. Let's make this yellow. Let's make this yellow. And we can keep these red, that's fine. I don't particularly care about this one back here. I am not planning on using that. I do wanna make this, once again, something I can see rolling, because I can't see circle rolling. So let's do arrow 4. Yeah, we can do arrow 4. And then let's make it big. Let's go 8. Is that enough? Okay, it's enough that I can see it rolling. Okay, so we've got that. Now we need to be able to move this and have our control go with it. Let's save where we are so far. So most basic is we get our control, and let's set a transform. We're going to keep this very simple for the for speed reasons, etc. We're going to be setting this with bone, and we want this to be, what are we doing? The root. So this is the root control I'm working on right now. Global space, compile. Do we have auto compile on? We do. It's interesting that I had to compile that. Yeah, our axes are super messed up, but it's not gonna matter because we're going to be using vectors. So you will hopefully be able to understand the idea with this. All right, so we can move, that's great. Now what we need to do is we need to basically rotate the wheel. So let's do this. We are going to, we know we need to set the transform. So let's copy this. We're going to, eventually we're going to be setting the transform of the wheel. All right, we know that at least. and it's going to freak out. And the reason it freaks out is because we're setting it basically to 0, 0 right now. So let's get the control. Let's get the control, and we will take, sure, we can take the transform right now. Okay, so we have some options. We could rotate the control to rotate the final bone, but either way, what we do need is we do need the concept of where we were before. And what I've seen used in, oh, actually, I really need to fix my project settings. I think for future ones, I'm going to create a default project where this stuff is already done. So we got middle mouse, and let's do rotate as well. These are just my preferred settings. Okay, save all. So I've seen I think I saw a hand, it was a hand thing, where what they were doing is they were storing information in the meta node. So let's do this. Let's add meta. Let's add a, no. Metadata. Set metadata. Set metadata. That's what we're looking for. We're going to set the metadata on, let's put it on the control, the wheel control. And what we are going to call this is previous transform. Okay, and the value is going to be the current value of the wheel. There's a couple ways we could do this, but I want to use the wheel. So let's get the transform. I'm going to get the transform of the bone, I think, initially. Let's try this. So let's get the wheel bone. We'll get it in global space, and we'll set that. Okay, so what that does is that every time it comes through here, whatever we do, we're setting the previous transform. So we have to use that as a reference. Great. So now back here, what I want to do is and this isn't going to do anything yet. What I want to do is I want to get the distance we have moved. This whole rig has moved. That's what I want. And the way I'm going to get that is I'm going to get the transform of the bone. Okay. And then I'm also going to get the metadata of the same bone, which is the wheel bone. And the metadata, the cool thing is once you put this in, it fills in. So that's previous transform. Okay, we're getting it. That's good. And this is a transform. So if we right click, cool, we can say transform. Awesome. And then we want the distance. And I want the distance between where it was and where it is. So this is where it was. This is where it was. This is where it is. So can we get the distance? I think I saw a distance between. That's good. So now we have a distance between. So that's how far we've traveled. Cool. Okay. Now, for some reason, something that's stuck in my head that I loved in school was geometry. So how far do we want to rotate this wheel when we move? And it's basically, we want the circumference. So we have the circumference of the wheel, and the circumference is pi times d, and d is the diameter in this case, and we know that the radius is, I believe it's about 34-ish, just from, we can look at it. We know what it is because if we look at the translation on this joint, we can see, even our joint translations are messed up. We can see this is about 34 in y. So let's call it 33.8. We'll go with 33.8. Okay, so, it's 33.8 times pi though. Hold on a second. And that's not 33.8, it's 33.8 times 2, because that's the diameter. So 33.8 times 2, that's the diameter, and then times pi. What? There's no pi? Where's my scientific? Okay, 33.8 times 2 times pi. Here's pi. Equals 212.37. So let's roll with that. 212.37. I'm going to multiply 212.37. Now I just did that to temporarily hold this. Okay, so we know that this is the circumference, and if you take the circumference, that's the distance, and you spread that out, and we know basically we want to do a degree per distance. So we want to take this number and divide by 360, I think. Hold on, let me think. 360. So 212 divided by 360 would be the number of degrees. So this is the number of degrees that we should move per, is it per centimeter? Sure, let's go. And then this is our total distance, so we should just multiply these two. So let's just multiply these two. Multiply this times this. That's going to be how far we're rotating the tire. And then we need to take this value and we need to plug it into the rotation of what here? Let's see here. That's setting the metadata. That's setting the transform of the wheel control of the bone to the transform of the wheel control. I do not think we want this. I think what we want is we want the translation from the wheel control. And then, yes, and then our rotation is going to be the rotation of the wheel control to Euler, because we need to add to it. So we got to go to Euler. Okay, hold on. Let me make some room here. We don't need all of this stuff down here. This just needs to be big enough for you all to see whether or not it's moving or not. And we can shrink this up. Okay, so now we have an Euler angle, and what we want to do is we want to add. I'm just curious if we just add in, which axis would that be? I think we want to add, I don't know which axis we want to use for this wheel. Let's just try, hold on, our wheel skeleton. If we look at this wheel, actually it's Z, because it's the Z axis. Okay, so we want to add a Z. So if we put, just for kicks, if we put 2 on here, okay, and then we go back to Euler, to Euler, from Euler. That will give us our quaternion, and that is what we are going to feed into the rotation of our joint. All right, so this is just an experiment. So it's in the right place, which is cool. The value that it's getting is getting the previous rotation of the control plus 2, and it's using that to set the joint. That's not really what we want, but I'm curious what it does, if anything. It does nothing. So we're setting the wheel bone, oh, interesting. We're setting the wheel bone in global space, but this rotation is in global space, but I don't think we want that because we're rotating around local space. So let's also get this in local space. And then that is what we're going to feed in here. And then from Euler, and let's go to global space, to world. Can we just do that? No, that doesn't work. Okay, hold on. And it's still not rotating. Okay, so let's see here. What are we gonna do? We have our control. Let me think. We're we're going to feed this in. We do want it to be the local space rotation. I think we want this to be, local space. Okay, and the problem is we need to, oh, interesting. If we put this in local space, okay, that lines it up. That's cool. Okay, but so far we're still not getting any rotations. Why is our wheel not rotating yet? So we're taking the control local space rotation. We're adding to it 2 degrees. Let's try 10 degrees. Is it just, oh, I saw it move. Okay, so it's moving, but it's not moving. And the reason, oh, because we're actually not taking the difference yet. Okay, so this was the difference. Global previous transform wheel, so multiply, this was our distance, and we're going to do that to here. It's definitely rotating now. That's something. Oh, look at that. Did you see that? The tire rolls. Okay, all our vectors are messed up, but the tire rolls, that's something. Okay. Okay, so let's see if we can't stabilize this a little bit. All right, so we have a distance that's being rolled, and it is the opposite of what it needs to be. So what that means is the distance is positive, we know that. This is how far we need to roll, we know that. Now we've got to figure out the direction, because what we could do is we could for example, we could just stick a multiply in here. And if I just do a -1, this is going to change this, I believe, to work. Okay, it definitely works going this way. I think it looks pretty good going this way. The speed of the roll, we could probably adjust. But at least it's rolling. However, when we get back to the origin, if we compile, we're not handling the opposite direction properly. So let's think about this. So that's fine. This way, we're rotating negative. Why is that? So we're adding, this needs to flip. This needs to flip based on whether or not the direction we're traveling is positive or negative relative to the root. Is that right? Okay, so let's do this. How do we find out which way that we are relative to the root? We have the previous position, we have the previous transform, this is a position in world space. Okay, what we could do is, and we also have, okay, so let's take, this is where we were before, this is where we are now. Okay, so let's subtract. This is going to give us a vector. This vector points in the direction of movement. Okay? So if we normalize this, that's the unit vector. I don't know if we need to do that yet, but hold on. So now we have a vector that's pointing in the direction of movement. We know that if, okay, so let's get the root. Let's get the root. Let's get the position. And let's get, oh, actually, wait a second. Let's get the rotation. And let's get vectors. There's a cool thing in here to vectors. So we can get the forward, the right, and the back, which is cool. If we take the right vector, which I believe is the z vector, and we dot product that with our direction of travel, that will tell us whether or not we are perpendicular. And if it's positive, it will be one way, and if it's negative, it will be the other way, which means we can't use this number, but what we can do, here, let me compile and save this just in case, because we are using control rig. Okay, so what we can do is we can use an if. And what we're going to if on is this greater than or equal to 0? And if that's true, let's take, I'm going to cheat this real quick just to turn these into floats. And one of these is going to be 1, and one of these is going to be -1. And we'll feed this into here. Okay, so theoretically, they're both wrong now. Okay, that's either we're not getting the right vector or this doesn't do what I think it does. The root control. Multiply, hold on. Let's print real quick, print. Okay, we are printing this result. Okay, -1 at 0. It's always -1. So either we've got the wrong axis or we're using the wrong control. So this is always -1. 1, -1, -1. Okay, so we were using the wrong axis. Okay, so if that's the case, oh, it's working. Did you see that? Oh, look at that, you all. Okay, so let me make this bigger so you all can see it now. Okay, so as the wheel moves right, it's rolling. As the wheel moves left, it's rolling. So the wheel is rolling now. That's great. Now we can get rid of our print. And here's the trick. What happens when this thing rotates? Okay, so the rotation case, this is probably the worst one. So if we rotate, oh my gosh, it works, y'all. That looks like it's working in all directions. Did we just get lucky, man? Okay, the interesting thing is there is a pop that's happening as this rotates around, as it rotates around this point. My guess is the vector's flipping. But overall, I'm pretty happy with where we are. Let's see if we increase the amount we are rotating. So rather than, I'm going to take this and I'm going to multiply this by, let's double our degrees. So how are we going to do that? Let's just add in another multiply here real quick. I want to make this a little more extreme to see how that looks. Compile. The tire does rotate pretty well, even on the corners. So like as it's turning, that's kind of cool. So if we get over here to the other side, okay, I think that's a win. I'm calling that a win. So recap, what did we end up doing? What was interesting about this? I remembered some old geometry math. That was kind of interesting. But specifically in here, what I'm interested in is this set transform metadata. Okay, what's cool about this set transform metadata is we're able to use it to even store things like previous values in time, which is kind of wild. So by setting this transform metadata, what happens is the first time through, everything's 0, this gets set to 0. Then the next time through, what happens is as the controller is moving, we're getting the world space of the wheel control. And we are comparing that to the previous, let's see here. Here it is. We're getting the world space, of the wheel bone. We're comparing that to the previous bone, and we're getting the distance between. And that's how we're determining how much we're supposed to rotate that tire by. And then the rest of this is literally just, this is all just math for circumference of a circle and all that kind of stuff. This is, so let's see here. If I was going to label this, this is going to be how much rotation, rotate much. That's much funnier. Okay, and then we will go, and then down here, this is all about the direction. That's the dot product. This is literally all about determining whether the wheel is going forward or backwards relative to the root control. Which way is the root control traveling? So let's comment on this. This is rotation direction, which is cool. Okay, and then as far as how this works, basically remember the dot product tells you whether or not two vectors are parallel or perpendicular, and it can be positive or negative, which is why we're checking to see if it's greater than or equal to 0. And then if it is, then we determine the direction, and the rest of this just feeds into our setting our current bone. Pretty straightforward. So at this point, what I'm going to do is I'm going to take this all and I'm going to package it up, get it ready. Maybe I'll work a little bit on that pop and then share that out with the community. Actually, no, let's fix the pop. All right, let's fix the pop. All right, so let's hop back in here and see if we can figure out what's going on with the pop. I know we can fix it. What we've got is we have all this makes sense. The interesting thing is we're getting the position of our wheel control, but we're setting the bone, but our control, oh, dude, our control's not rotating. Why are we using the wheel control here? Let's get the bone. Let's try the bone. Because maybe when it goes across the 0, okay. It still rotates, that's good. What happens when we come around the corner? Oh, no, it still pops. Global control. This is wrong. This previous transform, well, aren't we putting that on the... I'm putting that on the wheel control. I'm not putting that on this. So this needs to be the control and the wheel control. How does this even work? Oh, did you see that? That just popped. Oh, maybe that's all it was. Maybe it's just because we were getting the wrong thing. Okay, now it doesn't rotate at all. It popped because it doesn't rotate at all. Okay, let's see here. We are now getting the right thing. We're getting the wheel. I have a guess. Okay, so here's the deal. The reason it was working was a false positive almost. And the reason is because we were getting maybe the wheel control combined with the previous position not being correct. I think this is all happening in one tick. So the wheel is already where it is going to be. So what we need to do is we need to get the previous wheel local transform as well, I think. So here's what we'll do. Let's add another thing. And this one is going to be the wheel local space. And to clear this out, can we just type in previous transform local? Okay, cool. That works for putting on the control. That's fine. The value we're getting is going to be from our bone for the wheel local space. That's cool. And store that. Now, if we compile that, we now have the local space of the wheel. We're still not rotating it because we haven't plugged it in. So theoretically, if it is a tick issue and that it's not changing because there's no change, if we don't want the bone here anymore. We want the control. We want the wheel control, and we want... No, we don't want this. We want the metadata, y'all. Okay, so get metadata, because that's where it is. So get the metadata from the wheel bone. And the metadata we want is the previous local transform. And the value, it's weird to me that it doesn't know what the value is of this. Oh, actually, we had that before. Okay, so transform. And then let's get the rotation. Is this going to pop? I didn't see it pop. Does this compile? Also, the metadata, once again, we made the mistake. The metadata is not on the bone, it's on the control. So the wheel control. Technically, we're not really even using this control right now. It did just rotate. That's something. Ooh, maybe we've got it. All right, that's front to back. Oh, look at that. That was it. Okay, so we basically had a couple mistakes. Nope, wrong direction. Let's try this again. All right. That's it. That is it. Now we're there. All right, let's make this big because it deserves to be seen at the fullest. Okay, so we have our rotations in both directions, and the cool thing is now, even as we rotate, the tire is rotating around corners. Now it slides a little bit in the base there, but I think that's pretty cool from a quick play challenge standpoint. So let's call that an actual wrap. Round 2 this time, which is good. And I'm gonna, as I mentioned, I'm gonna package this up, send it out, and I'll get the video out to you all. As always, all feedback is welcome, especially if you happen to have rigged a wheel and it slides and does all those cool things. If you have a different way to calculate the rotations, whatever, feel free to share those, point people to other videos that you find, and so on. As always, thanks for checking out the video. Don't forget, a lot of our tutorials are in the live section. We do live weekly tutorials. We try to do them weekly. Keep an eye on the calendar for those. And I hope you all have an awesome rest of your day. My name's Kevin. Take it easy.